Do you have two different colors of colored pencils? That does not mean a pencil and a color. That means two different colors.
I mean, that's so many different colors.
And you have a bag of algebra tiles that you could share, but you have to have access to them one way or the other. You gotta have access to algebra tiles. Now, if you have multiple bags of algebra tiles at your desk, please try not to mix the bags. So if you share as a pair, please don't try to mix with the other pair at your table groupings. So, thank you very much. Don't make a big deal of this right now, but we are going to try again, maybe for the last time ever. Sit where you want and see if we can handle ourselves. I am hoping that a few days off school and some of us matured a little bit. Hoping that some of you are making different choices of necessarily who you sit with. Like, maybe I tell, I'll pick on Aiden since he just complimented me. Maybe I tell Aiden, we're good friends, but dude, I can't resist talking to you. I'm not going to sit with you during class. I'm going to sit with you at lunch. And maybe at AO, because sometimes we can get work done. But, maybe I got to adjust who I choose to sit with. Here's what we're going to do today. One last chance. I want questions from 424 about what the constant of proportionality is or what the unit rate is. Then we're going to do 431. Now I need your eyes up here for a minute. I need everybody's eyes up here for a minute. If I lose your eyes, I'll just stop talking. I need your eyes up here. So, today we are going to end up working on lesson 431. It is tomorrow's homework because I split up 424. We are having a mini mastery tomorrow on specifically finding unit rates and constant of proportionality, which is the same thing. Using that, graphing that, making a table with that, all the stuff we've been doing with the constant of proportionality and unit rates. So, if you have questions from previous homeworks, or the 424 homework, or whatever, about constant of proportionality or unit rate, I want to talk about that stuff right now before we move on to 431. That'll technically be tomorrow's homework, because we'll probably still have a little bit of it to finish tomorrow, but we're going to start working on it today. So, Aiden, you got questions? 467. Was that already assigned, or is that on this set tonight? So that is technically on tonight's set of homework. I'm going to slide that up onto the TV. But we might as well look at it anyway. So guys, if you haven't done 67 yet, this will really benefit you. So Alexa's looking at the shape at the right. She needs to make several different figures that are similar to it. So similar means same shape but different size, right? Your scale factor of 8/5. Will the new shape she creates be larger or smaller? So if my scale factor is bigger than 1, right? 8/5 being an improper fraction. What I do with my scale factor, Aiden, do you remember what we do with our scale factor? Yeah, scale factor is a multiplier. So we're going to multiply whatever dimensions of the shape we have. Let's say if this bottom was 12 and the top was maybe 8, and I don't know, this might also be 8, and that's to each of those values, we're going to multiply by 8/5. Will the number end up bigger or smaller? Bigger. Bigger than 1. So then with B, guys, some of you haven't done this yet, and we're essentially talking through your homework. With B, that's up to you. You just choose two different scale factors. Real easy ones are a scale factor of 1/2, scale factor of 2. One, you cut it in half, you shrink it down. One, you double in size. And then, so B, to get smaller, you got to use 1/2, 1/4, 1/8, something smaller than 1. But then C, you could use 2 to double and get bigger, and then you got to get creative for another one. You could do 2.5 or 3 or 8 or 14 or 754. any scale factor bigger than 1, you're going to get bigger. Other questions? Más preguntas, por favor. I mean, more questions, please. No other questions about finding constant proportionality, what we do with a table, what we do with the graph. So think in your head, if I gave you the unit rate, could you build a table? Could you build a graph and scale it, right? Put the numbers on the axes. Could you find a unit rate? If I tell you I bought 5 pounds of bananas for so much money, calculate the unit rate. Can you find the unit rate? And then work with it. Any last questions? All right. Draw a squiggly or, well, really, I don't know if you headed notes since we're on the same thing as we were doing last week, but let's make a new page for 431. And I don't know what we want to call this. Let me check exactly. Let's just name it like terms and algebra tiles, because I want you to have on there that this is where we're really going to start digging into algebra tiles a bit more, understanding what we're doing with them. So let's do 4, 3, 1, like terms and algebra. What does it mean when in math we talk about variables versus constants? So if we start talking about like terms, one of the first things we start talking about is variables. But what does that actually mean? So go ahead and write that down. If you don't know, especially you need to write this down. I don't know if we've talked about this in here or with your class at all yet. But there's huge research to every way you can put something in your brain, it gets in there better. You guys need to steal some people.
Go ahead, not here.
Okay. So does anybody want to take a guess at what a variable is or how we define it? Hopefully you all kind of have a good idea. You?
A variable is like an unknown number, so you use a letter to represent it, like X.
Yeah, so I'm going to go ahead and say an unknown value. We start to kind of use other words instead of number, and actually that's less letters. So you can go ahead and write this down. An unknown value represented with a letter like X. Guys, I don't think many of you are faster writers than me. Please make sure we're actually writing this down, because for all you know, actually, I am going to start to have vocab questions on your tests, just like on Chapter 3, and which you'll get those back here this week. I'm trying to plan out when that'll be best. We might get those back tomorrow with the mini mastery. But guys, some of you totally missed commutative and associative properties. Being straight up, some of you are way out in left field and you're making stuff up.
Oh.
I'm not joking. I repeated myself till I was blue in the face in class, not quite literally, but about what commutative, meaning to move, and associative, to associate, to group together. And some of you totally missed it. Totally missed it.
Like when you said about the sheep.
They group it. So, variables in math, any letter or symbol. We start to use other symbols to represent things. You can even use a smiley face as your variable. But what is a constant? So different than a variable. What is a constant? And this is one that people don't appreciate being a vocab word. Go ahead and write down constant. It's the antithesis. Oh, I've heard that word coming from social studies.
What?
Opposite. Right? It's like good guy, bad guy. They would be. It is the opposite of a variable. So if a variable is an unknown value, what do you think a constant is, Sky? A known value. And we can go ahead and say number, because if we know what it is, we know it's a number. A known number, like any number. So, example, 17. I don't know why I like 17. It's a fun number. 3/2, improper fractions. Proper fractions. Decimals. Even repeating decimals are constant values. Even pi. Now, it's a constant, but pi is actually irrational, and we'll get deeper into that as we go, because we can't write it as a fraction. But we know what it is. We know pi is 3.1415. We don't know where it ends, but we do know what it is.
When did we start?
A long, long time ago. Probably in a galaxy far away. All right, so this is going to be one of those situations where you do not want to work ahead of me. So, if you are guessing, and you can work with your group, what tile in your algebra tiles are the 1 tile, you may or may not know, pull out a 1 tile and try to make sure everyone at your group has a 1 tile.
Hey, Bob, can you just share with us? Sharing is not sharing, but still share.
Sharing is spreading germs. Don't do it.
I agree.
Spreading germs faster and giving everyone a virus.
Go get a child. No, just share.
And they're all the ones that
Yeah.
You have it. Why are you out?
All right, in your notes, you need to label picture, name, which actually I should have left a little bit more space out here. Name is also the area, and then perimeter. Now, in your picture space, please don't only leave a tiny little column. Our tiles get bigger. So as you go down your notes, we're going to need more space. So picture column, I don't know, probably make at least that big. Name doesn't need to be all that big. So label picture, name, and perimeter. Now, your 1 tile should be this little, like, navy or purple or whatever color you think this is. Or, on the back side, it's red.
Red is like negative.
Wait,
Red is the negative representation of the tile. So, trace this tile into your notes. So, try to hold it down with 1 finger and kind of work your way around.
With a color?
Yeah, with a color. Now, I'm not going to use color because that makes it harder to see. They are hard. They get easier as they get bigger. So once you trace it, try to clean it up a little bit, I guess. Now, you could, on the inside of this tile, put a 1. Because it is named the 1 tile. or 1 square.
Wow, 1 square is what I play all the time because I have no friends.
I just heard Mr. Estes talking with his creative start about how not everything needs a comment. Now, the reason it's a 1 tile is its dimensions are 1 by 1, so please label those dimensions over on your picture. And then the perimeter of this tile would be what? 4. 1, 1, 1, 1. The perimeter all the way around. The name is the area. So if you want to make another column just to help yourself out, the specific area of this tile is 1 unit squared.
Okay, now do we do like the next shape?
Now, yes, but be careful with working ahead because the next shape that we're going to do is the 5 tile, which people confuse because there's 2 different tiles that look similar. So check it out. This is not a 5 tile. This is. So find yourself a 5 tile.
Yes. Are we using, is this a positive or a negative?
We're going to do all of these positives for our pictures. Trace that. It should get easier.
Should it be the same color?
Yeah, do this one in the same color as your 1 tile. Because they're the same thing. Same color as your 1 tile. Now, once you trace it, you should have these like little dimples where it kind of notched in. Go ahead and connect those either with a light line or a dotted line. Now, why is this called a 5 tile? Because the dimension here is 5, the dimension here is 1, here is 5, over here is 1. Now careful, what's your perimeter?
12.
Ooh, 12. 5 on top, 5 on bottom, 2 from the ends. And our area here? 5 units squared. And then draw your line. If you don't have the area, you better know that this is the area. Like, it's going to be the same thing, but if you want to be able to have quick reference of like, oh, Mr. Hudson said a 5 tile, what is he talking about? It's a tile with area of 5. So, I mean, I bet you're probably right where we are. So if I was you, I'd add the area tile just because why not? Now, we're going to be changing colors now. Whatever your other color is. The next tile you want to find is the blue, like obviously blue. This one, the rectangle. That's the next tile that you want to find. Now, if you are working on graph paper, you are going to notice something interesting that should, for some of you, be extremely frustrating.
That is not the same size as
It will not line up. Now, the reason I'm not working on graph paper up here is because it gets busy on the screen. But if I try to line up this tile on my small graph paper, it is slightly over this line.
Oh my gosh, that's
Right, if I refocus it. Now, if I grab my big, no, that is my big square. If I grab my little squares, it still doesn't line up right. And because of that, this tile is our X tile. So trace it. If I was you, I would do it diagonally so you're not trying to line it up with graph paper.
Should we do this with the other color?
Yes, the other color. Because we don't know what this is. Your 1 tile and your 5 tile should be a certain color. Then write down your perimeter and your area, and this is where things start to get a little tough. Then write down your perimeter and your area for this X tile.
The area is X.
I got this is X.
The area is X. Did you say that any longer? Yes, I could.
The area is X. Yeah, the area is
The perimeter is Y.
no, the area is
So, you should, before you try to do the perimeter, label your edges on the X tile. The reason this is called an X tile, grab your 1 tile that you just had. This lines up on the one side of my 1 tile. But if I try to line it up with my 5 tile, now every year people say, well, it's like 3.7, or it's like, no. Because if we can't line it up perfectly, it doesn't work. So it lines up with the 1 tile, but then it's by X. So this is 1, and this is 1. But then that's X, that's X.
No, it's 4.
It's not 4. I will bet you all the money I don't even have, it's not 4. It does not line up correctly. Trust me, CPM did this very intentionally. So our perimeter here is going to be what? Ooh, what, Eva? From the ends. Yeah, from the ends, Eva says we have 2. And then from the top and bottom, she says we have 2 X's. Now, mathematically, we'd rather write the variable value first. So our perimeter is, and not like compared to the 2, but we put 2 times X plus 2. Now, it might help you to write this out as we get that from X plus 1 plus X plus 1.
Oh, so that's just 2X. And the area. No, that'd be 4X.
It would not be 4X. So, here's the moment where we're going to pause and make sure that we're all in the same place. The X tile does not line up with any countable, yeah, it's close, but any actual countable mark on the 5 tile. Like if I try to line it up at the 4, I'm overhanging at the edge over here. So we can't count this, so we just represent it with that variable X. I'm going to move my camera for a moment. So here's where people start to get confused. This is a dimension we can't determine. For now, we'll call it X, but we know that this is 1. Now, here's the weird thing. X could be 7,842. X could be 3, or 2, or negative 4 for all we know, but lengths can't really be negative, but actually in CPM we kind of can do that. So you cannot get stuck in your head thinking X is almost 4. Like you need to forget that right now. X is anything. This tile is stretchable. I really wish that they had a set of these that was like Stretch Armstrong. Remember him where you could like pull his arms like make it. Now his arms did get a little bit thinner, so I would need one of these where I could pull this tile and it would stay the same 1 thickness, right? Same thickness of 1, but get as long as I want it to be, or compress it down to be as short as I want it to be. This X tile is stretchable. Okay? I need you to imagine that right now. This X tile is stretchable. But the 1 is countable. The 1 stays the same. So I can't stretch it both directions. I can only stretch it out, like Stretch Armstrong. Stretch him out. Now, our area, what is X times 1? X, right? So if I think about length times width, my length is X, right? My width is 1. Trying to line that back up on the screen for you. That area is X. Now be careful. Units squared. Once I know what X is, if somebody tells me it's 8 inches, then I have my units. Maybe it's 2 miles, then I have my units. So the next and the last tile that we're going to do today, get out the X squared tile.
Oh, God.
Trace, label, and try to fill in all of your notes. Trace it, label it, fill in your notes. The blue. Because remember, X was blue. You should be using the same color you used for X. Whatever color in your notes you used for X, you should be using for the X squared. Just there, we got enough space. Did this in 6th grade or what? You're supposed to introduce and keep working. So this year, we're reminding you what they are and what they're called and what their dimensions are. Then we're going to start to work with them at a deeper level than you did last year. What are we doing? Do I need a handwritten indication for you? Or are you waiting for a color? You guys sharing colored pencils? Because you want to do the X squared, the same color you did. So you want to do that one blue also. Do something. Borrow something. So, guys, just to say it for a moment, a couple sets of the algebra tiles are clear. Don't, like, when we use these in class, try to avoid these. You want the flippable kind. Today, it's totally fine. They're the same size. But when we work with these, we want them to have a positive and negative side. These are clear and just have either clear blue or clear red. Grab the flippable kind. These are fine today, but it'll make your life easier to have the flippables.
Mr. Teacher, are you going to call us?
What do you mean am I going to tell you? That's no fun.
Confused.
What did we say?
I'm not confused, but like...
You should be mildly confused.
But like, it's you, so I don't know if it's like a trick question.
What is this edge length? X, right? What is this edge length? This edge? This edge? What is, so we said the name of this is X squared.
No, X squared.
Or you could write this as X squared tile. This is the last one we're doing today. So if we were going to name this guy with his area, what is an X times another X? Not X. Not 2 X's. Brendan, why? Squared means you're multiplying something by itself. So on this tile, write X squared inside of it. That is going to be this tile's name because that's his size. But be careful. What is our perimeter, Natalie? Thank you for volunteering.
Okay, it's
Yeah, so say that the more appropriate way. 4x, right? Because we have x plus x plus x. So if you want to write this out, x plus x plus x plus x.
So X times 4.
That I did that too. You saw that. And then the area we said we know is x times x, which turns out x squared. Then please put your tiles back in your bag. Hey, please be careful with the one tiles. They get lost really easy. Hang on to them for now. Hey, don't put them away. Don't put them away. Don't put them away. No, I didn't say put them away. I just said put them in your bag. Put them in your bag. All right, now I have a challenge for you. I have a challenge for you and your partner. We have about 10 minutes left. Well, whoever's sitting next to you. At your table group, now if there's 3 of you, just all work together. Bring it back. I'll know you're listening when I got your eyes. Now, we are going to start easy level, get harder, okay? So you can only use positives to start. Now, you can use a max of 5 different tiles, okay? On your table in front of you, I want you to set out 5 tiles of whatever you want, and then your partner, whoever's sitting next to you, across from you, whoever you want to partner up with, has to write out the combined value of the group. No more than 5 tiles, so you might end up with 5x squared, but I doubt it. I think you'll probably get more creative than that. Now, remember, there's tiles we're not using. We're not using the green ones, and we're not using like the purple ones. Set out 5. I'll show you what I mean.
Then don't give me yours, because I don't want one.
I realize I should have probably given an example first.
Okay. Yeah, Ava, you'll go one.
We don't need an example.
Real quick, I realized for some of you I probably need to give an example. I only said a minimum of 5 or a max of 5 tiles to keep this easy to start. If I laid out these 5 tiles, I cannot say I have 5 something. I can't, because they're not all the same. So I need to separate them out by what they are. What are these tiles? X squared tiles. How many of them do I have? 2. So I start with 2x squared plus, what's this? How many do I have? Ooh, only 1. These are actually different. These are 5 tiles plus 10. Right? That is what you're doing. You're trying to set up one for your partner to solve and see if they can get it right. Actually, let's make this easier. One person pull out 5 tiles. The other 3 solve them and then rotate who's doing what. One person pull out 5 tiles. Everybody else solve it. You should have not read up. You should have not read facing up. And we are not using purple. You don't yet know what that is. They can't use the purple.
I described the rainbow.
Wait, you can tell us?
Yeah, but really, you just have extra plus 4. You don't need to write times 4. You can just write 4.
You can always call
No, excuse me, I'm not frozen. I let them down, but then that one.
So, let's take responsibility for what happens.
I didn't get further. I was lying.
Okay, let's start.
There's also 1 tile. grab that.
Okay, I'm done.
Hey Sky, we're in math class right now. We should only use a positive right now. Yeah.
Alright. I'll put the next one out.
No, so each of those are x in the second, right? X squared. You have of the
No, X squared.
Alright, next one.
times x squared. You're trying to make it, you're trying to go further than you're able to go. It's just 3x squared times.
I'm getting all of these, man.
All right, Joey just asked a really good question.
Why do you have your notes out?
All right, bring it back up here real quick, and then we'll wrap things up. Joey just asked me a really good question about powers and like how we write things. We know that this is the x squared tile. So, and this is the stuff that like is different about how we teach now than how we used to. That x squared comes from, hey guys, this group is not really open right now. Can I get you for a second? This x squared comes from this dimension x, and the fact that a tile's a square, right? It's its area. Now when I go to talk about what I have combined, I cannot put the powers together because I don't do the 2 plus the 2 plus the 2 and have x to the 6. That is not how this works. What we're saying is how many, how many of the type do we have? The type is x squared. How many is 3? So we have 3 x squareds. But then if we look down here, can I add these up?
Yes.
Ignore the people in the hallway.
Yes.
Can I add these tiles up?
Yes. I vote yes.
So we haven't worked with this tile yet, right? If it's yet another, you don't have to write this down, I just want your focus up here, just absorbing this, right? If we have another thing we don't know, and we call these x, what might we call this?
Wow.
Sure, let's go ahead and say, if this dimension's y and that dimension's y, what would this tile be called? A y squared. Anyone play with the green tile and figure out what it's actually called? Yeah, it is a rectangle. It's not a square, right? But what is the name? Play with it for a moment. Grab a green and see if you can figure anything out. Hang on to that, Sky. Don't say it again. Grab a green, see if you can figure out what it is. It is a rectangle, not a square. You got it?
But like,
Oh, don't look at the cheat sheet. Alright, apparently some people found the cheat sheets. This dimension's x. This dimension's y. This tile is an XY tile. And this tile is just a Y tile. Alright, so I gotta wrap this lesson up so that we're done. Okay, so give me your eyes back up here for just another minute. This gets into the vocab that was the title of our lesson of like terms. Okay, so I need your attention. Those of you doodling or brain somewhere else, I need you up here. Like terms, how we're going to first start talking about them, literally means the same size object. X squared compared to y squared, even though they're both squares and they're both variable squares, X and y could be the same, but we don't know what they are, we cannot put them together. An x squared and an xy, again, not the same size, right? Can't put them together. So when we first start talking about like terms, what we're talking about, if we want to visualize it, is the same tile. So even though I got a y and a y squared and they share the y, they're not the same size tile. So I can't add them up. That would just be how my expression ends up looking. X or y squared plus xy plus y. So we're going to pick this up right there tomorrow. If you could, please put algebra tiles back in the boxes. Wherever you got them out, make sure your stuff is clipped in your binder. Have a wonderful day.
You too.
Thank you very much. Colored pencils, if you borrowed mine, please put them back. If you borrowed mine, please put them back.
I like variables.
How can you like something that you don't know?
Whoa, roasted.
I'm just asking genuinely. If you don't know what it is, how do you know you like it?
She's scared right now.
She likes mystery.
No, yeah.
That's why she watches Gravity Falls. We're not